Hello, in this video we are going to take a look at variables and we are going to look at actually setting and allocating some storage space for data that we already know a value for, so for initialized data. So the general format of creating a variable is like this. So if I say var1 colon db, I'll explain what the db part mean in a moment. And let's say if I put, I'll put a string in here. I'll say hi, and then we'll move this into the ECX register. So we'll say var1, and then we also need to move into the EDX register the actual length of what we're printing, how much we're printing. So it happens to be 2. There we go. So we got that printing out. So the general format is the variable name, the amount of space that you want it to take. Again, I want to touch on this in a second. Then the actual value itself. So this right here, this is essentially defining a byte. So there are a few different ones. There's db, dw, dd, dq, and dt. So db is define byte, which is, let me zoom out a bit, which is 1 byte. Remember, 8 bits in a byte. And dw is defining what's called a word, and in storage space that is 2 bytes. dd is defining a double word, which is, I think you can guess, because if it's a double word and if a word equals 2 bytes, this is going to be 4 bytes because it is double it. And let me zoom out a little bit more. There we go. Next is define a quad word. See if you can guess how many bytes this will take. Remember, a word is 2 bytes. So if it's a quad word, there's 4 of them. 2 times 4 is 8. I gave the answer. It's 8 bytes. And finally, dt is defining 10 bytes. So that's literally just stands for. So this is 10 bytes right here. So if you need to store something that's going to take larger than 1 byte, which is a reasonable amount of space to be fair, then you can use dw, dd, etc. And you just literally change this here. So if I change this one to dd, for example, which is a double word, 4 bytes, so 4 times the amount. As you can see, still works the same way, but obviously we don't need that much storage. So if I was to run it, and there we go. So that's really it for allocating storage space for data that we already know the value for. A few things to note is that every single byte of character is actually stored as its ASCII value in hexadecimal. Any negative numbers are converted essentially to the 2's complement representation, but again, we don't really need to concern ourselves with that at the moment. But over the next few videos, we're going to look at variables more and the different ways to create it in the assembly programming language. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video.